Okay, brilliant. So I'm the last talk, right? The whole conference.
Yes.
So let's have some
But
fun.
we are on time.
It's
never happened in the past.
Well, feel free to interrupt. I have no problem being interrupted. It's very important to me. I know there was one more talk on smart contracts, right, during the conference?
Yes.
So if anyone feels like they're kind of in the dark still about them, don't be afraid to interrupt with questions. Okay. So this is some work that I did with Ari Jules, who is a spectacular security professor we have at Cornell Tech. Cornell Tech, if you don't know, is the new tech campus that Cornell has built in the city. It was also done in conjunction with IC3, the Initiative for Cryptocurrencies and Contracts. It's a partnership between Cornell, Cornell Tech, a couple other amazing universities. Cornell Tech is where I got my computer science master's recently. I'm also a JD and a lawyer, also the CEO of an awesome computer vision startup called Uru. So sometimes you do research and you don't know if it's going to be relevant in the real world, right? In this case, I think the research we did turned out to be not only relevant but really prescient. So we wrapped this up and submitted to RuleML back in May. And in June, this happened, as some of you probably saw. Basically the most important smart contract ever, endowed with $250 million worth of virtual currency, was hacked. There was an imperfection in the code, and that allowed it to be drained of, it's actually over $50 million. When this happened, of course, people were eager for, people were looking for ways to alter or possibly undo the contract to stem the damage. And, of course, unfortunately, the creators of it hadn't done anything to create ways to alter or undo it. So recently, actually, the community agreed that the solution is going to be a hard fork of the entire Ethereum network. So this is a pretty, extensive undertaking. It's not a scalable solution every time there's a contract that has a problem. And the thing is, contracts will continue to have problems. They're hard to write. They're hard to test. And then you're putting them into this very dynamic environment. So things are going to continue to go wrong. And when they do, we want to have ways to alter and undo them.
What does hard fork mean?
Hard fork is sort of like a reset of the blockchain. They're going to go back in history in the blockchain prior to this DAO contract's creation. So the DAO is the name of the $250 million smart contract. Go back in time to before this contract was put on the blockchain, fork it, create a new blockchain, and then shift over there. That's my understanding.
They undo the contract.
What's that?
They will undo the contract.
They will undo the contract, and they'll also undo whatever else has happened on the blockchain since then. So it's kind of like restoring computer in an earlier state, right? So not a scalable solution. We need more scalable, standardized ways to undo these things when something unforeseen arises. So actually, this is a pop quiz. Can someone tell me what film? It is Blade Runner. So if you've seen Blade Runner, which I hope everyone here has, otherwise our nerd credentials are in jeopardy. If you've seen it, you might remember that this man, Eldon Tyrell, is the founder of Tyrell Corp, maker of human replicants, right? And here's the second part of the pop quiz. Does anyone remember the slogan of Tyrell Corp? Also, hint, also the title of a popular song from 1995 by White Zombie. It's more human than human. And I like to say that smart contracts are more contract than contract. What does this mean? Well, the purpose of contracts, I'm going to posit, is to deter opportunistic breach. The purpose of contract law is to deter opportunistic breach. I'm in good company in saying this. As Judge Posner of the Seventh Circuit has pointed out, this idea that the purpose of contracts is to deter opportunistic breach goes back as far as Hobbes' Leviathan from 1651. So what Hobbes points out is this. In nature, we can have an agreement. We can make promises to each other. But the moment that one of us, it becomes economically rational for one of us to breach that agreement, again, in nature, the covenant that we've made is essentially worthless. To restore value to these promises that we make, we decided at some point to have courts enforce them. Makes it easier to do business, to build a society. So the cool thing is, bringing, from Hobbes' Leviathan 1651 up to the present, smart contracts are kind of built around the same purpose. If you look at the seminal writings on smart contracts, including some by Nick Szabo, which I really like, you'll see that he describes smart contracts, and this is when it's really just a concept, right? He conceptualized smart contracts as the embedding in hardware and software of promises in a way that makes breach prohibitively expensive. And I like to think you can even, in a really robust smart contract, almost make it impossible. So, for example, the example Nick gives of a smart contract is actually a vending machine, right? So the gears and the coin return of the vending machine are a way to embed in hardware the promise of the vendor to deliver a tasty gumball to anyone who inserts a coin into the vending machine. And then a more modern example is, of course, something like Ethereum, which is a blockchain smart contract platform. And there, you're taking these promises between people and you're embedding them in code, putting it on the blockchain. So I think one thing that you'll see, both of these examples, the simple gumball machine, Ethereum, one thing they both have in common is security. Okay, so if we are embedding promises in hardware and software in order to thwart opportunistic breach, we actually create a new way to opportunistically breach them, which is to disrupt that hardware, right? So if we have an agreement, in a smart contract, one way I can breach is to simply just disrupt it. So I think any smart, robust contract, you'll see it has this quality of security. In the case of the gumball machine, it's the glass that's prohibiting you from reaching in and grabbing a gumball you didn't pay for in violation of this kind of contract. In Ethereum, it's the blockchain, the consensus protocol that's making it nearly impossible, or at least very hard, for you to change code embedding promises once it's on the blockchain. So this security in conjunction with the embedding of promises is what gives rise to all these really nice qualities that you hear people mention when it comes to contracts. That they're immutable, it's an immutable form of contract that can't be changed. That gives way to this kind of trustless trust. Now we can interact with other people and always know that the promises we made will be performed. Likewise, it gives rise to this concept of automatic enforcement, the contract enforcing these promises itself without the intervention of third parties like courts, which is, of course, really costly. So all of this is well and good, except this. When you lock down these promises and secure them inside a contract for the purpose of deterring opportunistic breach through the disruption of technology, you also end up securing them against any kind of disruption at all. And that sounds good until it sounds bad. And the reason it can be bad is that life is full of unforeseen eventualities, right? Things change. Contracts lose value in the eyes of the parties. This happens all the time. You could learn that the quarter someone inserted in your gumball machine was a fake quarter. We used to call them slugs. Or you could find that there was a coding error in your enormous smart contract. So when unforeseen eventualities like this happen, and they do all the time, in fact, they've been happening as long as we've had contracts, contract law has a set of really nice tools for going in and altering or undoing contracts. And we can actually look to these tools in creating a similar set of tools for smart contracts. So let me just run through these tools. You may be familiar with them. So there's a set of tools for changing contracts that people have made. By the way, I should have mentioned this at the outset. I'm trained, obviously, in Anglo-American contract law, so things differ around the world. Always interested in hearing about how things differ elsewhere. But in Anglo-American law, there's a set of tools for altering contracts. And the general idea here is that when a contract is legitimately altered, a court will stop enforcing, or it will refuse to enforce those provisions, those terms that have been altered, and then going forward, it will now start enforcing the new versions of those terms, right? This comes in three flavors. The first is called modification by right, which is that sometimes a contract gives the right to one party to go in and change terms, usually under certain conditions. A court will respect that as long as that right has been given to the party. There's also modification by agreement. So parties can agree, all the parties must agree, but if they do agree to modify a contract, then the court will also respect that modification. Lastly, reformation is where there may be no right to modify that has been given to a party. The parties may not come to an agreement to modify, but a court sometimes goes in and modifies the contract on its own or at the request of a party. That's called reformation. The classic example here is when there's a bilateral mistake. It will only do this on certain grounds. Bilateral mistake is one, and that's when both parties have like a misunderstanding of what the contract should have been versus what's been kind of encoded, and the court will go in and make what's on paper closer to what the parties actually agreed to. Likewise, there's a set of tools for undoing contracts. And again, there's three flavors. And the idea here is that a court will stop, if a contract is legitimately undone, the court will just no longer enforce that contract, right? Here we have termination by right, same thing. A party can reserve the right to terminate a contract, usually under certain conditions. Rescission by agreement is where all of the parties agree to undo a contract. A court will also recognize that. And lastly, the court may go in and rescind a contract. The classic reason here is fraud or duress. So as I talk about these tools, again, in contract law, you can see like a couple qualities emerging. I just want to highlight these. Again, the first is this notion of enforceability, where the court says, we will no longer enforce a contract that has been undone. We will no longer enforce terms that have been altered, but we will start enforcing new versions of terms that have been altered. There's also this idea of kind of permissioning happening, right? So, as you saw, if a party has a right to terminate or alter a contract, and that was set forth in the contract, a court will respect that. A specific court with jurisdiction has a right to go in and alter or undo a contract. Other courts don't. So again, we're very specific about who has the right to go in and make these, alter or undo contracts. There's also kind of a conditioning that happens sometimes. Like I said, a party may have the right to alter a contract only based on certain circumstances, certain events occurring. Then one other thing that's developed over the years is this idea that if a contract is undone or altered, we want to make sure that the parties are still made whole. So if a party has partially performed, that means they've performed on some of their promises in a contract, and then we decide to undo it. We want to make that party whole by compensating them for their partial performance. A really easy example here is just a down payment. So if you make a down payment on a mortgage loan, and then the loan is undone before the balance is paid, we will return that down payment to you. Okay, so those are the contract law tools. Turns out these map very poorly in some cases onto smart contracts. And I'll tell you why. Just to run through these qualities that I was just highlighting. So this idea of enforceability, right? We're saying that under the normal contract law rules, a court says we are not enforcing this version of the contract. We are not enforcing this contract that's been undone. But in a world where we are making automatically enforced smart contracts, that no longer has a lot of value, right? The contract is going to continue to be performed anyways. So it's kind of a farce. We have to deal with that somehow. There's also this permissioning thing. So we don't have courts around anymore to say this person has the right to alter the contract, this person has the right to undo it. We have to actually build that into these smart contracts somehow. The same goes for conditioning. So if something like altering the contract is conditioned on a certain event, a court is not around to police this and make sure that that actually happens. So we have to build that into the contract. And the same goes for partial performance. I think in order, keeping with the spirit of smart contracts, of kind of removing the need for third-party enforcement, it would be nice if we can also build this aspect into smart contracts. So in light of all this, in light of the inapplicability of contract law tools to smart contracts, and despite that, the need to stand on the shoulders of giants and draw what influence we can from contract law while we create ways to alter and undo smart contracts. In this paper, I sketch out some new standards for altering and undoing smart contracts. And the whole point here is really just to start sketching standards. People are not looking at ways to alter and undo smart contracts. We're not setting standards to measure code against. And I think this is kind of a shot over the bow, and I just want these standards to start being developed. That was the kind of impetus for this paper, really. So I sketched out some, and I'll run through those. So the first deals with this issue of enforceability. Like I said, it makes no sense to say that a contract is no longer enforceable if it's set to automatically be enforced. So our first standard might be that upon alteration or undoing of the contract, the auto performance of that contract must actually cease, right? For any altered terms or for undone contracts. Conversely, if we alter a contract, we want to initiate automatic performance of that smart contract for the new versions of the terms going forward.
Can
Yeah.
I just ask a
Yeah.
question back on that?
Of course.
So, I think a key thing, from the viewpoint of this community is, what does it mean to talk about the altered terms? So, a key thing is, so maybe you change one thing directly, but there's a whole lot of other stuff that depends on it.
Yeah.
So, one wants a notion of logical dependency for the incremental revision. So, deep in the algorithms for Ergo, I don't know if you were here when I gave the talks about
I
that.
wasn't.
Okay, but it does non-monotonic reasoning, it has negations failure, you have dynamic updating of knowledge, you can delete or add, and so it's keeping track of the intermediate steps, it's often called truth maintenance, which captures those dependencies and makes it efficient when you change something to detect what other step, maybe not precisely what depends on it, but at least a superset of what depends on it, so that you can go through that, examine it, recompute it, and figure out what are the implications of the changes. That seems to me really pretty crucial in this area.
Yeah, I'm 100% on board with that. I think the idea here is that, people aren't even thinking about these things. And actually, people aren't even taking steps so that their contracts are altered, can be altered in a reliable way. But absolutely, this is the kind of next level of work that has to take place is going, and that's how I'll wrap up the talk, but I think the idea is to go in, start creating standards, just even conceptually, but then also doing formal verification of them, and then thinking about how do we test these modules for altering and undoing smart contracts. So yeah, I think that's on point. Okay, so just some other standards that we might set forth for altering smart contracts. So this idea of permissioning, right, of making sure that only certain parties have the right, the power to go in and alter or undo contracts. That is something that I think we want to make the contract police itself. That should be in the software and hardware of the contract. We don't have courts around to do that policing. Same goes for conditionings. If you have elements of your smart contract terms that are conditioned on certain events, the policing of those conditions has to be inside the contract. If you're going outside the contract and asking for a court to police those conditions, then you're kind of corrupting the whole purpose of smart contracts and the efficiencies that they bring. And this one's actually one of the hardest ones, but in an ideal world, I think also we have ways to automatically compensate for any partial performance that has occurred when we go in to undo a smart contract. So the last part of this paper is spent taking these standards and proving that setting standards is no fool's errand by applying them to an existing smart contract platform and just trying to prove that we can build things with Ethereum that help get us towards these standards. Okay, so I'll just kind of walk through how we can try to meet these standards inside Ethereum. The paper has the nitty-gritty code, so definitely check it out if you like. In Ethereum, we have a couple ways to deal with this enforceability issue and to make sure that any automatic performance of a contract that's been undone or of terms that have been altered stops. For undoing a contract, there's a nice global function called self-destruct. In order to turn off contracts, to turn contracts on and off if they've been altered in a more granular way, you can use sort of conditioning on states. So if we have a term that's encapsulated by a function, we might have sort of a red light and green light Boolean even associated with that, such that if we alter that term, we switch the red light Boolean on, and that function can no longer be called. We can condition the whole function on that kind of Boolean. That's another approach here that I discussed in the paper. Honestly, the best way to go in and deal with this enforceability issue, and this was actually sketched kind of by the Ethereum founders in the white paper, in Vitalik's white paper, which is like the seminal paper for Ethereum, is the idea of using satellite contracts to deal with altering and undoing terms. So if we have a contract, we can move some of the terms encapsulated by functions into other contracts, separate, I like to call them satellite contracts, and have pointers inside the original main contract to these satellites. And if we need to alter terms, then that can be as simple as setting up a new contract with the altered function and then switching the pointers. The permissioning issue can be dealt with by conditioning functions. Like any terms that you're capturing with functions, you can condition those on being called by the right kind of caller. So we can imagine a world, maybe that's not too far off, where courts have Ethereum accounts, and only the right court has the right to come in and call a function that allows a contract to be altered or terminated. Likewise, conditioning can be dealt with by conditioning functions that alter or undo smart contracts on events, external events. If we have a contract that is, where a term is conditioned on maybe, the winner of a sports game or something, we might set up a data feed that feeds into the contract, and only if a certain sports score is registered by a variable in our contract does that function become callable. So that's a way to deal with conditioning that I sketch out in the paper. And lastly, there's this issue of partial performance. This is a much harder one. The way I sketch out in the paper of dealing with this on Ethereum is we could kind of create escrows inside contracts that collect any of the money involved in the contract, also log any partial performance that has occurred, log down payments, for example, and if the contract is undone, automatically pay those out. So some of the solutions in the paper, especially this last one, are sort of hacky, to be honest, and they feel incomplete, and I think that's the point here, is we need to get towards an era where these solutions are robust and can be basically commoditized, open sourced, where people can incorporate them into all of their smart contracts. So, in conclusion, we need ways to alter and undo smart contracts. Contract law has a nice set of tools for altering and undoing analog contracts. We can learn from that, although unfortunately a lot of those solutions fail when applied to smart contracts. So our goal should be to create a new set of standards for altering and undoing smart contracts that work for this new medium. The architects of smart contracts, just like the architects of contracts, as I showed you, have to install ways to alter and undo them. So that's it. Questions? Happy to answer all questions, even just smart contracts basics. Yeah, sure. Ben.
It seems that the current, it is very happy right now, is my impression
Yeah.
of the space. And part of the value of KR approach is to make it more verifiable, comprehensible, trustable in that sense, but also more modular,
Definitely.
more reusable.
Yep.
And I'm just kind of wondering how much are people focused on that aspect of it yet?
Not enough, I think, is the answer. I think that's in the wake of this DAO. So this DAO episode that I alluded to, this $250 million smart contract, I think a lot of the conversation focused on this, which is, maybe folks were coming in from an idealistic point of view where these things would not go wrong. That's been proven false. Now we know that these smart contracts and blockchain smart contracts here, there will be problems with them. We need ways to go in and alter and undo them. That code has to be, like you said, modularized. It has to be open sourced so that there's a broader community of people who are going in and testing it and perfecting it. And that all needs to start happening. Hopefully these events are kind of the impetus, the catalyst for all that to start happening. Yes?
Maybe just briefly on that, I think for the modularization, broadly speaking, the functionality isn't there in the language mostly, I think, but people also have to use it.
Yeah.
And personally, at the time, I didn't have the time to look at the DAO code, but if they didn't use it, then
Yeah, I mean, what we're saying here about altering, code for altering and undoing these smart contracts applies to basically all code for all smart contract code. There needs to be formal verification. There needs to be more modularization so that we have safe examples for everyone to use. Those don't exist right now, basically.
And so you asked it before to get some feedback on the contract and what could be events that affect the contract in other countries.
Yeah.
In the civil law tradition, especially in the Italian law and in the Spanish law, we have two ways of resolution or as you call it, rescission of a contract. What you call it would be called the resolution. We have something called the rescission, which is when the contract is concluded in state of need or in state of danger, and the other party is taking advantage of that.
Yeah.
What happens, the difference between the two type of resolution is in this one, all the effects are taken back as if the contract never existed.
Yeah.
And that actually is very different. So the consequences in terms of mass contract, I guess, should be very different.
Well, in Anglo-American contract law, the idea is, I think, similar actually, which is we try to make the parties whole when a contract is undone. That sounds like the civil law tradition that you're alluding to, right?
There is a bit of difference because when you have a solution of so somebody didn't actually comply,
Yeah.
you save the effects up to now, and then you equate on what was not even.
Yeah.
Where in the rescission, you have to really backtrack all effects, even if
Okay.
they were even. So that is a bit of a difference that could actually.
Yeah. Well, I mean, this points to another really important issue. So that gets raised every time I go and talk about these somewhere, which is we're dealing with this global platform with essentially no laws that has to somehow map itself onto the diverse laws, the diverse contract law even of the entire globe. That is a Herculean effort, and that's bound to cause a lot of problems. I mean, don't forget also that there could be criminal law, like implicated by these contracts, labor law, all kinds of things, and that could be tripped by these things. And we have no idea what's going to happen jurisdictionally. The DAO was, the DAO was a big contract that collapsed, but no one was hurt by it. But what happens when someone builds like Silk Road on Ethereum, right? How are we going to deal with that? Whose law is going to apply? These are huge questions that overhang the entire project and honestly overhang, smart contracts in general. So
Yeah, the only thing is about the effect. That's absolutely correct. But as an effect, there is this effect of backtracking
Yeah.
that I haven't seen in the presentation, but
Gotcha.
probably it could deserve its own dignity.
Yeah, it's interesting.
That's it. Thank you.
All right. Yes.
Maybe just for understanding, what is for you? Is there a difference between permissioning and kind of just the identification of users or accounts via private key, or is it just more or less the same?
No, I think like what I was trying to point out is in Ethereum that's a way to deal with like the kind of permissioning that's already done with these solutions, and I didn't really see another way to deal with it. So like I said, like in contract law, for you to be able to terminate a contract, you have to have that right given to you inside the contract. Or here's a better example, actually. When we have termination by agreement or rescission by agreement, we want to make sure all of the parties are on board. They all have to agree to it. You can't have like someone who's not on board with that, or a court won't recognize it. So like, how do we deal with that in a platform like Ethereum? I mean, one way is to log all of the accounts, that we associate with the contract members. This becomes a lot more difficult when we build a contract where people can join up, and we don't have foresight about who's going to be a party to it. But yeah, that's kind of like just the existing solution. And I think one other thing that I'm hinting at with this paper is there's also, maybe we want to think about structural solutions to some of these problems. So Ethereum's self-destruct global function is a nice architectural solution to these things. And I think we could use some more thinking about, like on that level, structural kind of solutions. Cool. Thanks so much.
Thank you.